Welcome to this video. We are going to see how to integrate Azure Container Registry with Azure Kubernetes Service. My name is Nilesh and I blog at handsonarchitect.com. So in this example, we are going to use RabbitMQ demo, which we had used in the earlier examples on my YouTube channel. So the example uses a producer.NET Core to produce a configurable number of messages onto a RabbitMQ, and then it uses the consumers which consume these messages in a batch of configured number of messages. The source code for this example is available on the GitHub link below, and I'll be reusing these different images, the Docker images, for this particular example. So let's look at the Docker images which are used in this example. I have a Tech Talks consumer and a producer, and these images are published to the public Dockerhub registry. So if I go to my Dockerhub account and I log in into my account, I can see these two images available. We've been using these images all throughout. So these are available on the public container images or Docker image registry. The name of the image is Nilesh Kule /Tech Talks producer. It has a tag RabbitMQ Keda, and same thing for the consumer. Now let's look at Azure Container Registry and why we might want to use a private registry as compared to a public registry. So some of the features that Azure Container Registry provides is it supports the Docker and Open Container Initiative images. So we can put the standard Docker images as well as other OCI compliant images onto the registry. It simplifies the container lifecycle management in terms of building, storing, securing the container images. So if we don't have Docker installed locally on our laptop or system, we can use the ACR to build the images remotely onto cloud and store it in the container registry. We can secure them by providing role-based access and who can access the images, who can push images into the container registry, who can pull images from the container registry. So this can be a very handy feature when we integrate the container registry with automated continuous integration and deployment tools like Azure DevOps or Jenkins or Bitbucket, for example. The container registry, private one, also provides the scan capabilities. So we can scan images for known vulnerabilities. This scan can be done when the images are stored inside the registry, as well as when the images are deployed onto a Kubernetes cluster and they are running at the runtime on the actual runtime environment like Kubernetes or OpenShift. And for the premium subscribers, we also have features like replicate. So we can replicate the container registry to 2 different data centers, and then these can enable us high availability. This also allows us to connect across different environments. Like Azure Container Registry has support for AKS, Azure Kubernetes Service. It also integrates with Azure Red Hat OpenShift, which is the OpenShift offering on Azure. We also have support for other services like the app service, machine learning, and Azure Batch. All these they can natively integrate with Azure Container Registry or ACR. So let's get into the demo mode and see how we can integrate ACR with AKS. So for this example, as I said, I'll be using these two images, the Tech Talks producer and Tech Talks consumer, which is currently stored in the Docker public registry. So let me go onto the command prompt and let's see what steps are required to migrate from a public container registry to a private one. First thing we need is to create a container registry. And if you've seen me from the previous examples, I prefer to store all these infrastructure related things into PowerShell scripts. I can create this using a set of AZ CLI commands, or it can be also created using the Azure portal. So in this example, I will use initialize ACR PowerShell script. This takes a certain number of parameters, like what is the subscription which needs to be used, what is the resource group name, resource group location, and the name of the container registry. So I start with setting the subscription on which I want to execute these commands. Then I create a resource group with the resource location, and then I create the container registry using ACR create command by providing the container registry name, the link for the resource group, and then what is the SKU to be used. In this case, I'm using a basic SKU, and I also enable the admin role. So this allows me to manage this container registry using an admin account. So I've already executed this script in the interest of time, and I've created it on the cloud. So let's go into Azure portal and look at the properties of this container registry. So as we saw in the script, I'm using a resource group name here called ACR resource group. So if I go into the ACR resource group, we can see that it has a container registry named ACR registry. So this is the name which I provided in the container registry name. And if I look at the details of this container registry, I have the control plane available here. I can store up to 10 gigabytes of images, and I have the support for ACR tasks. Like as I said, I can use build, run, publish, patch kind of tasks which are used as part of the automated deployment. I also have the integration with Aqua Security and Twistlocks. So these provides the security features which can be used for scanning of images. So for this particular demo, let's go and look at the repositories that we have. And currently we see that there are no repositories stored inside this particular registry. So the next step is to create a Kubernetes cluster and AKS cluster and integrate this ACR registry with that Kubernetes cluster. So again, I use initialize AKS script, a PowerShell script to create my cluster. It again has a similar set of input parameters like subscription name, resource group name, the location, the cluster name, the worker node count, Kubernetes version, and I've added a new parameter compared to the earlier script, which is the ACR container registry name or ACR registry name, and I specify the name of the container registry which I created in the earlier script. So this script again goes through a similar process of setting the subscription, then it creates a resource group, it creates the Kubernetes cluster in the next step. And here we see two changes. First one is enable managed identity, which is used to assign a managed identity for this Kubernetes cluster. So managed identity is like a service principal, but it lives within the scope of this AKS cluster service. So when we delete the AKS cluster, for example, the managed identity will also be deleted. And then we attach the ACR or the registry using attach ACR flag. So this will give the access to this container registry for this particular AKS cluster. And then we get the credentials and store it in our local kube config. So I've already gone ahead and done these two things. In the interest of time, I've already created the Kubernetes cluster because it does take some time to provision it. So if you look at the kubectl get nodes to see what nodes are created, we can see those two nodes which I specified in the create initialize AKS script are available here. We can also look at the pods which are running here. So my application requires a RabbitMQ as one of the dependency, and to save some time, I've already gone ahead and deployed the RabbitMQ cluster onto this particular AKS cluster, as well as SCADA, which is one of the prerequisite for my application. Next, we need to make changes on the Docker side of things. So first of all, let's go and log in into the Docker registry. Now to log in into Docker, we need to get the fully qualified name of our ACR container registry, the username and password, and use the Docker login command to log in. So for this purpose, I have again created a small script which will automate this process. I take the name of the container registry here, which is ngACR registry, and then I get the username by using the command ACR credential show. It stores the username into a variable named ACR username. Same way it stores the user password. So I'm not exposing any secrets onto the command line or anywhere. I'm using the commands to retrieve this in a secure way. And then I also get the fully qualified name of the registry. And once I have all these three details, I use the Docker login command to log in into this container registry with the user and the password specific to the container registry. So let's execute this particular command using Docker login. Sorry, this is under the PowerShell. So let's go here, Docker login. If I can spell it correctly, Docker login. So this script will go retrieve the ACR username, password, the fully qualified name of the container registry, and run the Docker login command. So once we have this, we are able to pull the images and push the images into our private registry. In order to pull and push the images, our first step is to build the image. So I need to make a small change to the Docker Compose file which I'm using. So let's look at the Docker Compose file which I used to build the two images using one command. So in this case, when I was using the public container registry, the Dockerhub, I was just giving my repository name Nilesh Kule, then the name of the image, which is Tech Talks Producer, and the tag. Now when we move to the private ACR container registry, I need to give the fully qualified name of the container registry, then the repository name, and then the image and the tag. I need to do this for the consumer image as well. So I follow the same syntax by specifying the fully qualified name, repository, the image name, and the tag. Once I have this, so here we see that the login is succeeded. So the script was successful in logging into our container registry. Now when I go and build the image, so in order to build the image, I have this Docker Compose build YAML file. I will use the Docker Compose command and the build parameter or the build flag. This will build my both the producer and the consumer images. And once I have these two images locally, we can also see that these are tagged with the container registry name. The same thing happens for the producer as well. So we use the container registry name, then the repository name, and the image name and the tag to tag it. Once we have it, let's go and push these images to our private container registry, which is the ACR. So I use Docker Compose and the push flag to push it. So while the images are getting pushed, we can also see what changes are required on the application side. So on the Kubernetes manifest side, I have two manifests for deploying the producer and the consumer. And these are referring to our public images currently. So if I go to the producer deployment file first, we can see here that we are using the public image or the public Dockerhub container registry. We change it the same way. The image now refers to the private container registry, the fully qualified name, the repository name, and the image name. Same thing is done for the consumer as well. So we change from the public Dockerhub registry to the private ACR container registry. And once the images are pushed to our ACR, we are able to pull them. So in order to pull this, I need to go and deploy those two manifests. So for deploying the manifest, I have this Tech Talks related script, which is to deploy. So deploy Tech Talks will go and deploy all the elements required for deploying those two manifest files onto our Kubernetes cluster. So now we have the TechTalks consumer and the producer created. Let's go and look at the pods. So you can see that the producer is already up and running. The consumer is also running. Since we have this running, we can go to Octant and get the IP of the service. In the services, we get this public IP and we generate the workload. So let me go to Postman and use that public IP to generate workload for the producer, which will generate 2500 messages onto the RabbitMQ. So let's first verify that there is nothing in the RabbitMQ. So we see the RabbitMQ queue is empty at the moment. So when I go and send this API request, if we get the success status as 200, that means 2500 messages would be generated and sent onto that RabbitMQ. Usually it doesn't take this much amount of time, but yeah, it did succeed here. Fine. So we see that 2500 messages are now populated onto the RabbitMQ, and soon we should see the consumers coming up and scaling, because we have 2500 messages to be processed. Each consumer will be processing about 50 messages in one batch. So if we go back and we run the same kubectl get commands, but with a watch flag now, we should see the consumer scaling. So here we can see now the number of consumers are increasing. Some of them have already started running. So let's go back to our Octant UI and see how many pods of the consumers are running. So we see there are already about 10 items running, or 9 pods for the consumers. So let this continue and finish off all the workload that is there to be processed. We can go back to the presentation and see where we had left earlier. So this is what we did as part of the steps of deploying our Docker images onto the private container registry. So initially we were using the public Dockerhub registry. We changed that to a private ACR or Azure Container Registry, and we pulled it using the fully qualified name of the registry. In order to sync, or in order to pull these images behind the scenes, when we create our AKS cluster, it creates a managed identity, and this managed identity has the ACR pull role. So we can verify this by going into our portal, and in the identity and access management for our registry, we should see access given to our service principal or the managed identity for ACR pull role. So when I go into IAM section of the overview page and I look at the role assignments, there is a role here which is for AKS-MQ cluster agent pool. So that is the name of the identity which is created for our AKS cluster, and we can see that it has a ACR pull role. So by means of this, the managed identity has a pull permission, and it's able to pull the images from our container registry and deploy them onto the AKS cluster. If you see here, the AKS cluster is residing in a different resource group, and the container registry is residing in a different resource group. And in spite of this, because of this permission which is given to the managed identity, we are able to pull those images. So we went through a 5-step process, I can say, to integrate Azure Container Registry, which is our private container registry, with the Azure Kubernetes Service or AKS cluster. We started with creating the ACR, a private registry. We enabled the admin role on that particular instance of the ACR registry. Then we created a Kubernetes cluster, and we enabled the managed identity at the time of creation, and we also attached the ACR registry, which we created in step 1. Once we have the cluster and the container registry ready, we moved on to the Docker side of things, where we logged into the ACR registry using Docker login command and using the username and password associated with this ACR registry. Then we built the Docker images, we tagged them with the name of the container registry, and finally we published them onto our private registry. Once we have the Docker images published, then we modified the container manifest or the Kubernetes manifest files, which are pulling these images from the ACR registry. And finally, we deployed them onto the AKS cluster. Please note that the steps for creating container images using Docker and attaching these to the ACR, these are independent of one another. So we don't have to follow the same steps. As long as we have the ACR registry created and the AKS cluster, which is attached to this ACR, the first three steps can be done in any order. As long as we have the elements which are required for creating and publishing the Docker registry and the Docker images, it should work fine. So we could create the images first and then we can create the AKS cluster. These are independent of one another. So that brings me to the end of this session or this demo. The source code for this particular demo is available on my GitHub repo. I hope you found it useful. In case you want to connect with me on any of the social media sites, the links are available here. You can connect with me using any of these. So thank you for watching this video. I hope you like it. If you find it useful, please share it and subscribe to the channel. Thank you once again for watching this.